Network intrusion detection can give you some really interesting insights into your network and alert you to potential threats. I've been using a very popular tool called Suricata lately, and having spent a bit of time trawling through documentation, I thought, you know what this needs? A nice, easy, getting started guide. Welcome back to the Pro Tech Show. Suricata is a network intrusion detection and prevention system. I say detection and prevention because it can operate in two ways. One is it stands at the side and watches your network and alerts you to anything suspicious going on. This is detection mode. The other is it sits right in the middle of your network traffic, and if it sees anything suspicious, it says no and blocks it outright. This is prevention mode. You're watching a getting started guide, so start with detection. This isn't magic. Suricata is not psychic. It's making informed guesses as to the intention of network traffic, but it will get things wrong, especially in the early stages before you've tweaked it. You want some time to review and adjust it before you block anything. If you go straight to prevention, you'll almost certainly break your network. Suricata is used in a lot of commercial security products, but it's actually free. It's the underlying engine that inspects your network traffic and detects anomalies, but it's often paired with analytics platforms like Elasticsearch or comprehensive security suites. We're not going to cover that in this video. We're just looking at getting Suricata installed and then tweaking it to make the data useful. If enough of you make it to the end and comment though, I can do a follow-up where we collect the data into something pretty. For now, let's jump over to our Linux server to get it installed. It is available for Windows, BSD and Mac, but most of the guides and documentation are Linux orientated, so I think you'll have an easier time in Linux. I'm going to briefly show you two flavours of Linux because there's a tiny difference at the start. So this one is running Ubuntu 22.04 and this one is running Rocky Linux 8. Rocky is a rebuild of Red Hat Enterprise Linux, so anything that applies to Rocky should equally apply to Red Hat, AlmaLinux or Oracle Linux. They're all the same by design. I'm going to assume you know enough to get Linux running and edit a text file. Installing Linux itself is beyond the scope of this video, but there are plenty on YouTube. First up, let's check for a Suricata package. For Ubuntu, that's apt list suricata, and for Rocky, it's dnf list suricata. Ubuntu shows 6.0.4 and Rocky shows nothing. That's because Red Hat, and therefore Rocky, ships with a more limited number of packages compared to other Linux distros. Red Hat is enterprise focused and comes with commercial support, so this is a way of them drawing a box around the software that they have specifically curated and are responsible for supporting. To enable additional software, you need to add the EPEL repo, Extra Packages for Enterprise Linux. This software, much like Red Hat, originates with the Fedora project, which is Red Hat's upstream development distro. So they're created by a team of people in a Red Hat-owned project, specifically to be used with Red Hat-based distributions like Rocky, but they are not covered by Red Hat's commercial support. Having said that, neither is Rocky, so let's crack on. Enable EPEL with dnf install EPL-release, and now if we check for Suricata, it's there, but it's an old version. By the way, a lot of the commands here will require admin privileges, so I'll be prefixing many of them with sudo, but I'm not going to call it out every time. If you get a permissions error, just check you sudoed. The Ubuntu version isn't bang up to date either. The latest version at the time of recording is 6.0.8. To get the latest version, we need to get it from the people behind Suricata, the Open Information Security Foundation. We can enable their community repo in Ubuntu with add-apt-repository, then ppa:/oisf/suricata-stable. On Rocky, it's dnf-copr enable @oisf/suricata-6.0, although you'll presumably need to put a different version number at the end of that in the future. You can get these commands from the official documentation, which I'll link in the video description. Now if we check again on both servers, they have the latest version of Suricata available, and we can install it on Ubuntu with apt-install suricata or on Rocky with dnf-install suricata. At this point I'm going to drop the Ubuntu server and stick with Rocky because the steps are going to be the same. Before you go further, type ip-add and check the name of your network interface. It's not LO, that's a loopback interface. If using a different distribution and ip-add doesn't work, try ifconfig. You want the one with your IP address on it. In my case, that's eth0. Now let's jump into the main Suricata configuration file. You'll find that at etc suricata, then suricata.yaml. I'm using Vim, use whatever text editor you're comfortable with. The first thing we want to do is change the home net here near the top. There are a few examples here. The hash signs are comments, so anything starting with a hash is ignored. meaning the only home net that matters is the first one. By default, it includes all private IP address ranges, but you should change it to match your own network. You can have a look at the other settings, but by default they all reference your home net. The exclamation mark in front of the external net means anything that isn't your home net. The next setting to look at tells Suricata which network interface to use. It's called AF-packet. If you're using Vim like me, you can search for it by entering / in command mode, then AF- and enter should be enough to find it. Mine's set to ETH0 out of the box, which is handy because if you remember, when we checked our interface using IPAdd, mine was called ETH0, so I don't need to make any changes. You might need to change this if your interface name is different, or if you have multiple and want to select a specific one. There are a lot of options in here and it's worth reading up on them, but this is enough to get started. Save the file and quit. In order to detect threats hidden within your network, Suricata needs some rules. It provides a default set, but we can give it more threat intelligence to work with. Run suricata-update space list-sources to see what we have available. These are provided by third parties. Some of these are free, others are commercial. If we look at Proofpoint for example, they provide one of each. There's the Emerging Threats Open Rule Set, which is free, and the Emerging Threats Pro Rule Set, which is paid. Have a look, Google the rule sets to see what they do, and choose the ones that you want. To enable them, it's suricata-update space enable-source and then the name of the rule set. For example, to enable the free Emerging Threats Open Rule Set from Proofpoint, it's suricata-update space enable-source et/open. As you can imagine, Suricata's rule sets get updated fairly regularly, so we need to download a fresh copy. To do that, it's suricata-update. You'll get some warnings here about protocols that weren't configured and have been set to enabled. You'll find these settings in the suricata.yaml file that we were in previously, and you can tweak them to explicitly enable or disable them so Suricata knows whether you care about the traffic. I'm going to leave it as is for now, with them getting enabled by default in version 6. The warnings are there to tell you that in a later version, if you've not explicitly enabled them in the file, Suricata will turn them off instead of on. You want to run Suricata update every so often to get the latest detection rules. But you probably don't want to literally log on and type this every time, so I'm going to set up a cron job to do it automatically. That's crontab-e to edit. Using crontab is safer than editing the file directly and protects you from silly mistakes. We want to run Suricata update, and to apply the new rules, you can either restart the service, or you can use Suricata SC to load them without restarting. That requires more memory to hold both sets temporarily, but it means no service interruption. If you're not familiar with cron, you can copy what I'm doing and it will run every 6 hours. A little tip, while it's not strictly necessary to include the full path to executables, it is good practice. If you just use the executable name, it will almost certainly work. But it might also be exploitable if an attacker gets onto the system and uses a bit of path manipulation to trick it into running the wrong file. Right, we've talked about restarting the service, but we've not actually started it yet ourselves. That system control enables Suricata to set it to start automatically after a reboot, and system control start Suricata to start it now. That's Suricata running and you're now doing intrusion detection, but at the moment the only network traffic it can see is its own. If you want Suricata to see the rest of your network traffic, you need to mirror the network traffic to your Suricata server. How exactly you achieve this will depend on your network setup, so I can't give you a direct answer, but the words you're looking for are port mirroring, port monitoring, span, short for switch port analyzer, and promiscuous mode. For some examples, in VMware, if you're using a vSphere standard vSwitch, you can enable promiscuous mode on the vSwitch. Then any virtual machine on the switch can view all traffic from the same switch. If you have a distributed switch, you can do proper port mirroring beyond that switch. In Hyper-V, under the network adapter's advanced features, you'll find mirroring mode. Set your Suricata virtual machine as the destination and your other machines as sources to view their traffic. If you're using a physical Cisco switch, then it's span or monitor you're looking for. If in doubt, look up the manual for your physical or virtual network switches to find out how they do it. Once you've got the traffic mirrored to Suricata, you're ready to start detecting intrusions into your network. But how do you know it's working? There's a handy website from 3CoreSec that you can use to generate safe but suspicious looking traffic. The website is testmynids.org, and there's nothing much here. If you follow the link to the GitHub project though, you'll find a script for running some tests. We'll just use the first one because you don't even need their script to run the test, you just need to visit a website. You can see the address here, testmynids.org/uid/index.html. If I go to that site, you just see a bit of text with a root user ID. This isn't malicious, there's nothing dangerous about this response. If I run sudo id to check my user ID when elevated to root on my Linux machine here, you'll see a similar result. The reason Suricata thinks it's suspicious is because that is the output you see when you check your user ID on a Unix machine and you're running as root. Except this has been spat across the network, unencrypted, by a website. That's normal output if you're operating a server as root. It's not normal for a website to respond with, and could indicate that this website has been breached and the attacker is exploiting it to run commands with root privileges. Except in this case it doesn't. It's literally just the response the website gives anytime you visit this page in order to trigger Suricata. To find our alerts, there are two log files we need to check. These are located in var log Suricata. The first is called eve.json and the second is called fast.log. Fast.log is the easiest for a human to read and the most concise. It outputs a single line of text every time an alert is generated. Eve.json isn't quite so readable as it's JSON based and outputs a lot more noise because it includes more events than just alerts. But really, this log is intended to be fed to an automated system to be ingested and analysed. Remember, if you want to follow up where we ingest these logs and do something with them, let me know in the comments. Let's show this in action by tailing fast.log and using this test website to trigger an alert. There you go, that's your alert, so you know Suricata is working. Suricata may be working, but if you leave it like this, then chances are it's going to generate a ton of spam, because it will alert you to a lot of things you won't actually care about. You therefore need to tweak the detections by disabling rules you don't care about and suppressing alerts for legitimate traffic. Let's look at how to disable rules first. You need to create a file called disable.conf in etc Suricata. This file won't exist until you create it. You can disable rules individually by adding their signature ID to this file, one per line. You can find the signature by looking at the alerts in fast.log. It's this number between the colons inside the square brackets. The first number is the generator ID, and you can include that too, but it's not required. If we add that signature ID to disable.conf, you will no longer get alerts for this test website. You can also disable groups of rules if you want to turn off a whole bunch at once. The syntax is group : and then the name of the file containing the rules you want to disable. You can use the full file name or a wildcard if you want to disable multiple. You'll find the rules files under user/share/suricata/rules. The stream events rules tend to generate a ton of noise, so we'll add that in here to disable all of the rules in that file. Most of the alerts it generates are from incomplete TCP sessions. There are network scanning tools that perform incomplete TCP handshakes to try and avoid detection, but on most networks you'll typically find a pile of incomplete sessions from misbehaving hardware or software. In a perfect world, we wouldn't have any imperfect software, and network transmissions would be 100% reliable. But in the real world, this doesn't happen, and most of these alerts will be rubbish. One final method you can use to disable rules are regular expressions. This can help if you want to get rid of a bunch of similar alerts without listing the signatures individually, but don't want to disable an entire rules file. Have a look in fast.log, and if there are any patterns in the text that you can build a regular expression from, then you can add it to disable.conf using the format re : then the regular expression. Once we've done this, then we need to run suricata-update to rebuild our rules, and then tell Suricata to reload its rules. This is because when we run Suricata update, it reads in rules from all of the configured sources and then merges them all together into a single file that it uses for detecting suspicious traffic. As it does this, it will check the rules against disable.conf, and if it finds a match, that rule won't get included in the live rules file. So until we run a rules update, the changes to disable.conf have no immediate effect. That's how to disable rules, but sometimes you'll come across alerts that are legitimate in certain circumstances, and you want to prevent alerts when those legitimate circumstances apply, but still get alerted the rest of the time. In this case, disabling the rules won't meet your needs, because that will disable them all of the time. An example of this is my Veeam backup server. During a normal backup run, it will connect to Windows virtual machines it backs up, and it will remotely create a service within the operating system to run some application quiescing tasks. This is perfectly normal, but Suricata sees one IP address remotely connecting to and executing code on a bunch of other servers, and it thinks that looks suspicious. We don't want a pile of alerts every time the backups run, but this could be a sign of lateral movement by an attacker across our network, so we don't want to disable the rules altogether. Instead, we can add a suppression rule that will prevent alerts if the suspicious traffic originates at the IP address of our backup server. These suppression rules are set in the file threshold.config, also in the etc/suricata directory. The syntax for these rules is suppress genid, then the generator ID number, sig ID, then the signature ID number, track, then either by_source, by_dest, or by_either, depending on whether you want to suppress based on the source IP address, the destination IP address, or either of them. Then IP and the IP address or subnet you want to suppress. Again, you can find the generator and signature IDs by looking at the alerts in fast.log. The generator ID is usually 1. Between the disable and suppression rules, you should be able to tune Suricata to filter out the noise and leave you with just meaningful alerts. It can be quite enlightening to see what pops up. For example, running it on my home network showed me that a media streaming app was sending unencrypted information over port 443, which is supposed to be reserved for encrypted HTTPS traffic. Just because an application uses a supposedly secure port doesn't mean it's actually secure, and Suricata can alert you to such misbehaviours. One last thing you should check before we leave Suricata's logs behind is that you have the logrotate tool installed. If not, in my case, it's dnf install logrotate to get it installed. Those Suricata log files will grow very large over time. Suricata creates a configuration for logrotate automatically to keep them under control, but that only works if logrotate is actually installed. That's you set up with a basic functioning Suricata install. Whilst it is functional, reading text files is kind of a boring way to use it, so comment if this interests you and I'll put the next video up here where we integrate it with something shiny. Please remember that whilst intrusion detection is a really good thing to be doing, most breaches come about due to compromised passwords, so the best thing you can do to protect yourself is to stop using passwords. Watch this video to learn about how you can actually do that. Then once you've secured your accounts, you can come back and learn more about intrusion detection.